Thank you for joining this webinar. My name is Shiri Ivtsan and I'm a product manager at WhiteSource. So today we're going to look into container security and really having a deep dive and understanding both the risks in container security, but also how to avoid them, remediate them, and do this automatically. So let's look a little bit into the history of microservices and container. So a few years ago, before containers were brought, so we were using monolithic architecture. This basically means that all your services are under one main server. And the approach today is really to go into microservices. And the reasons for that are probably known to everyone. So it's a lot faster, both in terms of implementation, development, deploying new changes, and also it's kind of easier for new developers to understand and get into business faster. It also helps us a lot with scaling services. So for example, you could scale one microservice without scaling the other. So let's say your database is loaded, you can only scale the database without scaling the other parts of your application. So containers have a lot of advantages. Basically, you can build them very easily. You ship them a lot faster, and you can run them on any environment. So containers are immutable. So this means they should be completely stateless. And you can run them on any environment, whether if it's Windows, Linux, no matter what the operating system is. And it's also a lot faster to do this process. What we didn't have, of course, in monolithic services. Now, if we look into the open source world, so the open source world is related to containers, of course. You can see that about 97 of the developers actually rely on open source components when developing. And this actually evolved very quickly. We see that today most of the developers use open source components all the time. And how is this connected even to containers? So with the need to ship our services and our applications a lot faster, we needed to use open source. And if you look at the container world, for example, Docker, Kubernetes, Red Hat, so you see that a lot of that is actually based on open source. So now let's look at the risks at open source. So open source is great. It helps us to not to build anything from scratch because we can rely on things that other people already wrote and use existing libraries. But there is, of course, a risk with that because as we adopt open source, the hackers also understand that this is something that can actually exploit. So we see a lot of open source vulnerabilities lately. And this number keeps on growing. In terms of what are the challenges with containers, so we see that the open source challenge is the #1 challenging area that was pronounced in particular by developers. This is based on a survey that WhiteSource performed around a year ago that included more than 700 developers across the world. So we can see that there are some common ways of handling security vulnerabilities, and if you are a DevOps, a developer, or a security person, you're probably familiar with these approaches. So basically it goes like that. The security teams analyze and then they prioritize the vulnerabilities. So let's say that they actually look at it because that doesn't happen everywhere. The security team will actually get a list from scanning tools, dependency scanning of all the vulnerabilities. Then basically they will send emails or open Jira tasks for the developers to actually remediate the vulnerabilities. But closing the loop is very hard. First of all, the developers are not always familiar with the security vulnerabilities. So it's a little bit challenging to understand what is the security vulnerability and what is the way to remediate it. Also, we need to understand whether it actually affects our software. So there are a lot of challenges with that. Of course, the security team doesn't always know that the developer actually fixed the issue. So this takes a lot of time, and we can understand that it doesn't really fit with the approach of CI/CD, continuous deployment, continuous integration. We want to ship our applications a lot faster, and the security process is really slowing us down. Another important friction that we have is between security teams, DevOps, and developers. So it's not only that the security team and the security aspect is making us a lot more slower in the process, it's also causing friction between different teams. So the security people, they basically get a list and they want to remediate all the vulnerabilities. But the DevOps actually have a completely different task. They need to make sure that all the services are running, to make sure that everything is working properly. Maybe they care also about costs and about performance. They don't really care about security. Then we also have the developers who doesn't really care about security as well. They have their own tasks, their own features that they need to implement. So we see that this is causing a friction. The developers are getting tasks from the security people, but they don't really know how to remediate them. So our approach, and this is what I'm going to be speaking about today, is basically on how to bake security into the existing workflows. Because we understand that if we do this based on emails, it wouldn't really work with the pace of development as we have it today. We have software companies that are releasing every hour, having a build almost 12 times a day. So this is really challenging, handling security vulnerabilities like that, especially when the security vulnerabilities keep on growing. So let's start with some questions that will help you understand where you are in terms of security in your containers and where you are in terms of vulnerabilities. So the first question would be whether or not you use a private registry. So a registry is actually where you keep your images. So after we have the Docker file, we've actually built an image and we have to store it somewhere. So typical places would be Docker Hub, ECR, Google Container Registry, Azure Container Registry, or Artifactory. Now, in all of these places almost, you can decide whether your image is public or if it's private. Then the second question would be when you actually use a public registry, like taking just a random image from Docker Hub. Do you actually sign the image to make sure that no one changed it after you took it? The third question would be, do you regularly scan your images? And by scanning the images, I mean, do you scan for dependencies? Do you scan for security vulnerabilities to understand whether your image is actually safe to use? And then the last question would be how quickly are images rebuilt with security fixes? So this is a very important question because we know that security vulnerabilities appear every day. So we think that the average number of new CVEs by the NVD is 3 per day. So we know that we have new security vulnerabilities all the time. And one of the most important things to do if you want to make sure you're safe is to remediate quickly and to rebuild your software quickly. So basically, let's start with the first step. The first step would be the CI/CD gate. So after you develop your software and you build it, what we want to do as part of having a continuous security approach would be to actually integrate the security testing into the build and into the CI/CD process. So whether you have builds twice a day, every week, or every month, you want the tests to be integrated into the process. And this is relevant not only for your functional tests, but also for your security tests. So you can have, for example, a dependency tool that will automatically scan every build. Now, what do we actually do when we find a vulnerability in one of our builds or one of our applications? So what we do is we use automated policies to actually fail the builds when they have issues. So for example, if I have a functional issue or a functional bug, of course, everyone knows that I will automatically fail the build. Now we want to give that approach to security as well. So this means that if I have a high severity security vulnerability, I will automatically fail the build and let the developers know that they need to change something. So what we basically say here is we want to scan across the lifecycle. We want to start with the development, continue to the build, which we actually discussed just right now, and then continue to the container registry and to the deployment. So let's look at that. So the first point with container registries is that you have to use trusted sources. So this means that the best approach would be to use a private registry, a registry where your images are not public, and you need an authentication like a user and a password to actually enter and see the images. This way, no one can actually push images if they are not authenticated. So this is a very important step. If you take images from public sources, which is fine, of course, everyone does that, you would want to scan the images in order to make sure that no one changes the image after it's actually in the container registry. The next step would be not to use defaults. So what we actually want to do is to enable role-based access control, or RBAC, into the container orchestration. So now we're talking about your container orchestration. So we are one step after the registries, and the container orchestration is actually, it can be Kubernetes, it can be Docker Swarm, Rancher, can be deployed in AWS, ECR, in AWS, in GCP, in Azure, or on your own data center. Basically, if you're using Kubernetes or any other container orchestration tool to control your containers, just make sure that you're using a role-based access control. This way, a user actually needs to have a specific privilege in order to get to the API resources. So we can see this example from Kubernetes, where you actually have on the right-hand side, you have the operations. So that would be get, list, watch, create, patch, delete. So all kinds of actions that you can make. Then you actually have the API resources. So a resource can be a pod, a service, a deployment. And then we can grant different access to different subjects. So a developer would get the right only to list or get the pods, but an administrator can actually create pods or delete them. So this is very important. And role-based access is not only for actual users, it's also for other pods or other resources within the cluster. And a few versions ago in Kubernetes, this was actually not the default. So we need to make sure that even if we take a solution, whether if it's open source or something commercial, we need to make sure that it complies with our security policy. So if our policy is not to use role-based, is to use role-based access, we need to make sure that this is actually the case in your container orchestration. The next step would actually be to use namespaces to establish security boundaries. So namespaces are sort of logical way to sort of like, you can think about it as folders with permissions. So basically a specific business unit, or for example, a task like QA can be in its own namespace so that you don't mix namespaces. And then you can grant access to people only for the QA resources and not for the production resources, as an example. So it's very important to use namespaces inside your cluster, whether if it's Kubernetes or any other cluster, basically. So it's exactly the same thing as using accounts for QA or giving different permissions within your cloud provider or within your actual servers. It's exactly the same thing within your container orchestration. The next step would be to manage your deployments. So now we're at the final step, the deployment step. You want to prevent deployment of images with known vulnerabilities. So let's say that you went over all the process, so you've done your tests in the build stage, you've done your tests inside the image registries, and now you are in the final gate, which is the deployment to your orchestration tool right before production. So in this step, you want to actually make a final check that you don't have any security vulnerabilities. So let's say that it took some time between the moment that you scanned it in the build, and it took a few days before you actually deploy it into production, and you want to make sure that there are no new security vulnerabilities. Or for example, if you get a specific component from a third-party vendor, you want to scan that as well. So it's very important. One of the things that you can do is you can use the built-in Kubernetes admission controllers in order to fail builds, pods or resources that have security vulnerabilities. The next point would be not to use root users. So really prevent the deployment of containers that require root. This is a very important point because any container that has a root access to your cluster can basically do anything. So even if you do have RBAC, this is very, very dangerous. So just remember, before you deploy any container to your cluster, make sure it doesn't require a root access. The next step would be to validate the image signatures. So we spoke a few minutes ago about signing every image. So it's also important when you actually deploy to validate that the image has the right signature to make sure that it wasn't modified between the stage where you pushed it to the container registry until the step where you actually deployed it to your container orchestration tool. The last step, I guess, would be to monitor for new vulnerabilities. So even after we did everything according to the best practices, as I mentioned, there are new security vulnerabilities almost every day. So we need to make sure, even after we are in production and already have everything deployed, we need to make sure that we monitor our software and our cluster for new vulnerabilities that will be actually published. So this is very important. Now, to conclude everything, so we went over what are containers and why people use them. Then we spoke a little bit about what are the risks in containers and specifically in open source. And we spoke about the main ways to actually avoid these and use private registries and sign the images and use all the trusted sources, not to use defaults, and to manage your deployments in a smart way. So this would be the first steps to do if you want to secure your clusters in your containers. Then the next step would probably be to automate everything within the CI/CD gates. So I really hope you enjoy this webinar. Feel free to reach out at product@whitesourcesoftware.com.